temperature depends on the depth. Temperature is the dependent, which is the y. Okay, so we're going to put temperature. This is one area some of us can improve on, is putting our labels on the graph. That is in degrees Celsius. And they've given you the labels here. Their depth in meters. Now, sometimes the trickiest part is what should you count by on your scale. You don't want it too small, but you don't want it too big. You want it to fit nicely in this window of the graph that you have. If you make a really tiny graph, if all your points are really tight together, it's going to be hard to create your prediction equation, your line of best fit. If they're too far spread out, it's going to be the same situation. So you look at kind of what you're counting by here. Do we have to put 2,500 on here? No. Okay, you don't have to have that 2,500, because that's the question mark. So really just looking at those 5 data points. What might we count by there? We have to go from 0 to 2,000. 500? How many lines does that take up then? 4 lines. So that put my entire graph in this little area over here. I have all this to work with. So probably more than 500. So like a break in the graph, you're talking about right here. But we have a 0 to use. So we don't want to do a break because we have 0, 300, 500, 1,000, 2,000 all put on there. Okay. Yeah. So 200 would use up how many lines? Yeah, 10 lines. So that sounds pretty good. Now, do I have to label every line? No. And that's going to save some room on here. You can be like, okay, this is going to be 400, 800, 2,000. And don't be afraid to try something and be like, no, I don't like how this looks, and erase it and do it again. Okay? That's why you have pencils. Okay? It's okay to not know what to do the first time, but the important thing is that you try something, that you guess and you figure it out. The more you try it, the more you do this, the easier it will be to know what to count by. Temperature, look at your range, so it goes from 6 to 22. So do I put, since 22 is listed first, do I put that on the bottom? Okay, you still counts up. So we're going to count by 2's here. 4, 8, 10, 12. So make our scatter plot. So now we're going to put our points on here. So 0, 22. 320. Don't be copying down my dots. Be looking at your data points and figuring out where they're at. So you need to open your book. Go to page 95. You right, Bethany? Once you get your points on there, the next thing will be a line of best fit. And if you, this is a part you really have to use pencil first, because this one may take a couple tries. You want to try to get a line that goes through all the points and kind of think of the points as a cloud, and you want the line to go right through the middle of that cloud. Sometimes the general idea is try to get as many points on one side as the other side, but of course here we have only 5 dots, so that won't work. You can use your ruler or straight edge to try to figure out where it should be. What does this dot here on the y-axis tell us? This one's kind of unique, a little bit different here. What does that 022 tell us? Yeah. What do we call it when it's on the y-axis? That's our y-intercept. So would that be a good point to go through for sure? Okay. Landed on the shelf. Okay. So that might be, now, do you have to? Not necessarily, but that might be a good starting point. That might make things a little bit easier. If you can go through a point, if you have a point that's close, I'd say absolutely go through it. So in this case, I mean, if you draw it, this would be another option to draw it, kind of maybe right through there. That'd be kind of in the middle as well. But this is a y-intercept, and since they're giving us a y-intercept, and the y-intercept isn't that far off, it might be okay to just kind of use that as a point. You kind of go right through there. Does that look okay? So that one, I mean, again, this is every line going to be exactly the same when you're working on this? No. Your lines will be different than someone else's. So as long as you're close, your final answer should be close to each other, you'll be okay. Right? So now that I have a line, what's the next thing I have to find? Oh, we have to line of best fit, describe the correlation. So positive or negative. Okay, so we have a negative correlation. If your points are helter-skelter all over the place, you'd have no correlation. Okay, this one you have a line of best fit, so there is a correlation. So B, they help you out. It says use 2 ordered pairs to write a prediction equation. You do not have to use ordered pairs that they've given you here. We want to use ordered pairs on the line. Okay? So, sorry. You want to use ordered pairs that are on the line. So that also is why it's helpful to at least have one of them. So we're going to use 022. And you want to find another one that's on the line. Try to do it on the other side of the graph. Okay? So if I'm using this one on the left, I want to try to find a point over here that I can use. Maybe this one right here looks like it's about 1605. Okay, don't put the two dots close to each other because it's really easy to get off then. Think of angles. If I'm scanning from my left side to the right side on the second row from Dawson to Cassandra, that's only about 10 feet maybe, okay? So my eyes go 10 feet here to here. If I take that same angle that I have here and stretch it farther out, okay, if you just go to Main Street, I'd be scanning from west of this intersection here in the school clear over here. So you see how my eyes would travel a farther distance? So the same thing happens here. If you get 2 points that are really close to each other, if I would choose a point up here that's really close to this one, you could be off a little bit, and your line could be way off down here. So you want to choose 2 points that are farther apart to be more accurate, okay? So get points that are further apart. From here on out, it's stuff that we've done. Okay, so once we have 2 points, what's the next thing to find? Before we do that, the 4-point slope form, you need to find the... Yeah, so we're going to work towards the prediction equation. To do that, we're going to find the rate of change between these 2 points. So I'll get some steps down for you. So choose 2 points on the line. And that's where we're saying, choose the 2 points that are one on the left end, one on the right end. Write in blue so you can see it. So once we have the 2 points, we're going to use the slope formula to find our rate of change. So choose 2 points on the line, use the slope formula, right, find the rate of change. And then we're going to use point slope form to find the prediction equation. So if you still needed some practice with that point slope form, here it is. The response is, thank you, Mr. Leitner. I did need more practice. Some of these you will get decimals. You can go ahead and use the decimals rather than weird fractions. So what do you get for your rate of change? It's going to be probably pretty small. Are we always all going to choose the same points? No. So our numbers may not be exact, but they should be close. Should be close to each other. So about -1/100, 0.01. We go a little bit more, 0.01.